Welcome viewers, in this video we will see the digital register. The type is serial input and serial output, SISO. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The type is serial input and serial output, SISO type of register. Then we know that the register is made up of a flip-flop. Flip-flop is the temporary storage device. So it will store the 1-bit data. Now first we will see the block diagram. Block diagram of the serial input and serial output SISO digital register. So there are 4 registers available. It's made up of the D flip-flop. Flip-flop 3, 2, 1 and 0. These three, this serial input, the data is sent by serially and it is passing through serial also, and output also taken as serial. The data input is serial as well as the data output also serial. So that this is the D input, this is the output, present state. The clock pulse is given to all the flip-flop. What is the nature of the D flip-flop? The D flip-flop, the input is D. This Qn is the present state, Qn plus 1 is the next state. Right? D is the one. D flip-flop having only one input. The output is present state, next state. So this next state, normally in flip-flop, the next state is depends upon present state and input. But in case of D flip-flop, whatever may be the present state, the D value will be reflected as the next state. Suppose D is 0 means Qn plus 1 will be 0. D is 1 means Qn plus 1 will be 1. Whatever may be Qn, it may be 0 or 1, whatever the value what is available here will be reflected in Qn plus 1. That is, next state is depends upon only the D input. It will not bother about the previous state. That is the nature of the D flip-flop. So whatever may be the data we are sending, the D, if the D is 1, D3 is 1 means Q3 also 1. The D3 is 0 means Q3 also 0. So that we are easily passing the data, right? So the next state value is purely depends upon the D input. It will not bother about the previous state. That is the nature of the D flip-flop, right? So we have flip-flop 0, 1, 2 and 3. Totally 4 flip-flops are available. Now we'll see the description. In all the flip-flop, be initially in the reset condition. That is Q3, Q2, Q1, Q0 is 0. Reset condition. It is 0. If an entry of the 4-bit binary number 111 is made to the register, we need to store the data 111. 4 ones need to store in the 4 flip-flop. This number should be applied to D in input. D in is the first input with LSB bit applied first. The D input of flip-flop 3 is D3 is connected in the serial data input. D in. The output of F of 3, Q3 is connected to the input of the next flip-flop D2 and so on. That is, the data is applied to the flip-flop 3. The output of flip-flop 3, Q3, is applied to flip-flop 2, second flip-flop. Then output of second flip-flop applied to the third. Like that it is going, right? The data input is given to first flip-flop. Output of first flip-flop is given to second. Thereby third, fourth, like that. That is the order. Now we'll see the what happened if the data is given to the flip-flop. Now we'll see the detailed diagram. So the data what we need to store is 1, 1, 1, 1, right? So this is the data in. Data in is given to the D3, flip-flop 3. Output of Q3 is given to D2. Output of Q2 is given to D1. Output of Q1 due to D0. Finally Q0 is the output, right? So the initially it is 0. All the output of all the flip-flops are 0. The data what we need to store is 1, 1, 1, 1, right? 4 ones, right? So initially we are applying 1 to the D in. So step 1 we are applying 1 to the D3. What happened? This D3 will be available in Q3. Initially it is 1. This 0 will be applied to the next flip-flop. This 0 applied to the next flip-flop. This 0 applied to the next flip-flop. The data will move. Initially all are 0. When 1 is applied, the 1 will be appear in the Q3. The already available data 0 is moved to Q2 like that. Right? So we are applying 1. So that this 0 will appear to the next flip-flop. This 0 applied to the next flip-flop. This 0 applied to next flip-flop. The data is moving in forward direction. In step 2, again one more 1 is applied. What happened? This 1 will go to the next flip-flop. This 0 go to the next flip-flop. This 0 go to the next flip-flop. So that it become 1, 1, 0, 0. Initially 0, 0, all 0, 0. While applying only 1, it become 1, 0, 0, 0. While applying next one, it become 1, 1, 0, 0. That is, data is moving one by one. Again, one more is 1 is applied to the D in. What happened? This one will go to the next flip-flop. This one go to the next flip-flop. This 0 go to the next flip-flop. Now it become 1, 1, 1, 0. Triple 1, 0. Again, one more 1 is applied because we need to store 1, 1, 1, 1. What happened? This one will go to the next flip-flop. This one go to the next flip-flop. This one go to the next flip-flop. So that finally it become 1, 1, 1. After 4 steps, we got our required data 1, 1, 1. That is our required data. We need to store 1, 1, 1, 1 in all the 4 flip-flop. Right? So we already discussed D flip-flop. The D input will reflected in the Q. Right? So initially all are 0. First only 1 is applied. Then it become 1, 0, 0, 0. One more 1 is applied. What happened? This one will go to next step. This 0 go to next step. Like that it will move. So it become 1, 1, 0, 0. Again one more 1 is applied. So that the outputs are moving. So it become 1, 1, 1, 1. In step 4, while applying one more 1, all become 1. So finally we got this required data 1, 1, 1 will be stored. Right? I will see the description for further understanding. Before application of signal, class signal, Q3, Q2, Q1, Q0 is 0, 0. And apply LSB bit of number to be entered in D in. Right? That so D in equal to D3 equal to 1. So on the first step, initially all are 0. In the first step, we are applying D3 as 1. Apply the clock pulse on the first falling edge of the clock. FF flip-flop 3 is set to and store the data in the format 0, 1, 0, 0, 0. That is Q3, Q2, Q1, Q0 will be 1, 0, 0, 0. Initially, all are 0. When the D in is applied to the third flip-flop, D3 is 1. While applying the clock pulse, the flip-flop is set and the data now become 1, 0, 0, 0. Now we'll see what will happen in the next step. So while applying the next bit to D in, next bit also 1. So D in is 1. As soon as the next negative edge of the clock pulse, F of 2 will be set and the stored data will be 1, 1, 0, 0. Right? The data from the F of 3 is applied to F of 2, that will set. So it become 1, 1, 0, 0. Then apply the next bit to be stored. Next bit also 1. This 1 is applied to D in. Apply the clock pulse. As soon as the third negative edge of the clock pulse, F of 1 will be set and the output will be modified to 1, 1, 1, 0. Now the data become 1, 1, 1, 0. Similarly, when D in is 1, with the fourth negative clock pulse arrived, the stored data will be 1, 1, 1, 1. Right? Finally, we got the required data. Now we'll see the truth table. For the further understanding, we will refer the truth table. So the data what we need to store is 1, 1, 1, 1. So the clock pulse, the D in, that is Q3, flip-flop 3. Q3 is applied to D2. Q2 applied to D2. Q1 applied to D1. Finally Q0. So the initially all the values are 0, 0, 0. In the step 1, during the first clock pulse, 1 is applied. So this 1 is goes to the Q3. this the data available here is moved to the next flip-flop. So it becomes this 0 is applied here, this 0 is applied, this 0 is applied. So it becomes 1 0 0 0. In the step 2, one more 1 is applied. So that will go to the Q3. The what is available already Q3 will go to Q2. This D2 will go to D1. D1 will go to D0. So it becomes 1 1 0 0. In step 3 again one more 1 is applied. So it will go to Q3. This already data what is available, Q3 will go to Q2. D2 will go to D1. Then D1 will go to Q0. So it becomes 1 1 1 0. Again in step 4 one more 1 is applied because our data is 1 1 1 1. So this one will go to Q3. The Q3 what is already available will go to Q2. Q2 will go to Q1. Q1 will go to Q0. So that 1 1 1 1. Finally we got the data. So this is the direction of data travel. While applying one, the data are moved to the next position. Right. That is. So finally we got the required output. Now we'll see the waveform. How the clock pulses are applied, how the data are moved. So this is the waveform clock pulse. 1, 2, 3. We have 4 data we need to store. 1, 1, 1, 4 bit. So 4 clock pulse is there. So this is the stored data. The D in initially 0. Q3, Q2, Q1 all are 0 only. Right. After during the first clock pulse, the D in is applied. So initially it is 0 0 0. During first clock pulse, the D in is applied. Data 1 is applied. So it becomes 1 0 0 0. In Q2, this 1 will be now applied here. So during second clock pulse, the Q2 become higher. This Q3 is already higher on high level. Q3 is already high level. After second clock pulse, Q2 become high level. So 1 1 0 0. In Q1, during the third clock pulse, it become higher. This Q3, Q2 already in high level. Thereafter it is high level only. So now become 1 1 1 0. After applying the fourth clock pulse, Q3 also high level. Q1, Q2, Q3 already in high level. So it is 1 1 1 1. Right. So the first is 1 is applied to Q3, it become high level. After clock pulse, this Q3 is transferred to Q2. So this also become high level. Now this Q2 is transferred to Q1. So Q1 also high level. Q1 is transferred to Q0. So that also high level. Right. So the data what we need to store is available 1 1 1 1. So in this video we discuss the serial input, serial output digital register, how the data are stored. We see the description, basic block diagram. It is constructed using the D flip-flop. D flip-flop nature is the D input will be reflected in the next state of the flip-flop. Whatever may be the present state, D0 means next state will be 0. D1 means next state will be 1. So that will be very useful for transferring the data. When the 1 is applied, the output of flip-flop is 1. When 0 is applied, the output of flip-flop is 0. So the data what we require is passed to the input of the flip-flop. The same data is available at the output because D flip-flop, the output next state is depends upon the D input. D input will be reflected as the next state. Then we discuss how the data is moving in the basic block diagram. We discuss truth table and waveform also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.